Yes, very good afternoon, my dear students. Today, we will see a few questions from the topic electrochemistry. So it's a very easy topic, but it involves a few numericals. You should be, as somehow you should find some tactics to solve those numericals. So let us start from the simple question from this topic electrochemistry. See the first question. 1 molar aqueous solution of which of the following compound is the best conductor of electric current? Here, regarding the conduction of electricity, there are two types of substances which conduct electricity. One is metallic conductors. Here, the conduction is due to the movement of the electrons. So, we call them electronic conductors. Another is electrolytes. Electrolytes are the substances which conduct electricity not in their solid state, but either in their molten state or in their aqueous solution. Here the conduction is due to the movement of the ions. So ions, though they are present in the solid state, ions will have freedom to move only when you melt it or only when you dissolve it in water. That's what we call aqueous solution. Then which furnishes more number of ions? Obviously, the conductance will be more. Now let us see the compounds what they are given. Acetic acid, hydrochloric acid, ammonia, fructose. Here fructose is a non-electrolyte. It does not furnish any ions. So its conductance will be 0. Lowest conductance 0. Coming to the other two, acetic acid and ammonia. They are electrolytes. Of course, they are weak electrolytes. They ionize only to a small extent. So their solution furnishes very few ions. So their conductance will be very low. They ionize partially. So the conductance of their aqueous solution will be very low. Now come to hydrochloric acid. Hydrochloric acid is strong electrolyte. It ionizes completely. So a solution of hydrochloric acid furnishes a large number of ions. So among these four, it is the hydrochloric acid whose conductance will be highest. Highest conductance will be of hydrochloric acid. One thing is it is a strong electrolyte. It furnishes a large number of ions in its aqueous solution. Second thing is not only the number of ions, but also the size. That also counts. Hydrogen being the smallest ion, it moves fastest. Ionic mobility will be maximum. So on this ground, we can say hydrochloric acid conductance is maximum. So the right option is B. For this, right option is a B. Now let us move to the next question. Yes, second one. The correct order of the mobility of the alkali metal ions in the aqueous solution is. So first group is called alkali metal. First group is called alkali metals. Now in this alkali metal, potassium, rubidium, sodium, lithium, like that it is there. Now let us see the alkali metals. So it is lithium, which is first, then comes sodium, next, and then comes potassium, then comes rubidium, then comes cesium. Of course, francium is a radioactive element. Now, any group from top to bottom, the size increases. The size increases from top to bottom. So lithium is the smallest, and then cesium is the biggest one if you leave francium because it is radioactive. Now all are monovalent. They form ions. Lithium form lithium ion, sodium form sodium ion, potassium form potassium ion, rubidium form rubidium ion, so also. Now the size of the ion also follows the same order. lithium smallest ion, little bigger is sodium ion, still bigger is potassium ion, still bigger is rubidium ion. Now, in their molten state, now smaller the ion, more is the speed. So in the molten state, lithium is the fastest ion, and then sodium little less, and rubidium will be the slowest ion. But what they have asked is not in the molten state. They have asked it in a aqueous solution. Aqueous solution means dissolve it in water. In aqueous solution, that is when it is dissolved in water, each ion gets solvated. Each ion gets solvated means water molecules gets attached to those ions. Then all the ions are not solvated to the same extent. Smaller the ion, larger are the number of water molecules attached to that. So in that way, lithium gets solvated to the maximum extent, sodium little less, potassium little less, then rubidium very less. Okay. Now ion, when it is solvated, it cannot move alone. It has to go along with the water molecules which are attached to that. So compared to these other ions, lithium gets solvated to maximum extent, sodium gets solvated a little less, potassium gets solvated still less, then rubidium gets solvated to least. So comparatively now, in their aqueous solution, because of the solvation, lithium becomes the slowest ion. Though it is the fastest in the molten state, in the aqueous solution, lithium becomes the slowest ion. Lithium becomes the slowest ion, and rubidium becomes the fastest ion. See the question now. The correct order of the mobility of the alkali metal ions in aqueous solution is. So here, which one is the fastest? Rubidium is the fastest. Then comes potassium. Then comes sodium. Then comes lithium. Rubidium. Then comes potassium. Then comes sodium, and the slowest will be lithium. So option B is the right answer. For this, option B is the right answer. If the same question were asked in the molten state, the option would have been lithium would have been the fastest, then would have been sodium, then would have been potassium, then would have been rubidium. This is in the molten state. What they have asked is in aqueous solution. So the right option is B. Right option is B. Now we will move on to the next question now. We'll move on to the next question. Yes, see here. 0.1 molar solution of an electrolyte AB placed in a conductivity cell with electrodes 4 centimeter apart and each with area of cross section equal to 2 square centimeter was found to have a resistance of 200 ohms. The molar conductivity of the solution will be, say, it involves some numericals you have to work out. Now, a few formulation. You know, conductivity cell is the instrument which is used to measure the conductivity. Right? Each conductivity cell is fitted with 2 electrodes, platinum electrode coated with platinum black. We call it platinized platinum electrodes. Each of area A, maybe square centimeter, separated by a distance of L centimeter. Every conductivity cell has got a cell constant. It is represented by G star, is for cell constant, G star. So when the area of the electrode is given and the distance of separation is given, cell constant is L by A. This is the distance of separation divided by area of a cross section of each electrode. L, see the question now. Point to solution. Yes, each with area of cross section equal to 2 square centimeter. 4, distance is 4 centimeter. And area of cross section is 2 centimeter square. So it will be 2 per centimeter, because centimeters there is in the numerator, centimeter square is in the denominator. So what you are getting is 2 per centimeter. This is the cell constant. For that conductivity cell constant is fixed. It will not change. Now, what they have given? They have given the resistance of the solution. Resistance of the solution. Now, one more formula I have to use. Very important formula, even for your board examination. G star is equal to R into K. G star is equal to R into K. Where G star is the cell constant, R is the resistance, K is the conductivity. Knowing the cell constant, what you already calculated here, and the resistance, what has been already given, you can find out the conductivity. Therefore, conductivity, it is actually kappa, we can call it as K. Conductivity kappa is equal to G star by R. K is equal to G star by R. G star is already given, how much? 2. It is per centimeter. 2 per centimeter, G star. R they are given 200 ohms. 200 ohms. R. So 2 by 200, it is nothing but 1 by 100, or I can write it as 10 to the power 2. Now let me write the unit. Per centimeter, anyway it is in the numerator. Ohm, when it goes to the numerator, it becomes per. So it is per ohm. What we call it Simon per centimeter. So what is Simon? Simon is nothing but a per ohm. Per ohm is called Simon. Simon per centimeter. Right? So 10 to the power minus 2. Sorry, 10 to the power 1 by 100. That is 10 to the power minus 2. 2 by 200, 1 by 100. 1 by 100 means 0.01, or you can better write it as 10 to the power minus 2 Simon per centimeter. What is this Simon? Per ohm. When it ohm goes to the numerator, it becomes per ohm. That itself is Simon. Yes. Now, conductivity is known. Last one step is there. Molar conductivity of the solution. So, different formulae are there for the molar conductivity. When this conductivity is in terms of Simon per centimeter, now the molar conductivity lambda is equal to 1000 K by C, where C is the concentration. So 1000 will be there in the numerator when it is given in terms of centimeter. If the same thing is in Simon per meter, 1000 comes in the denominator. Okay. If the concentration is in terms of mole per meter cube, which is not a commonly used unit, then 1000 disappears. Now for this, the formula, what you have to use is this. Lambda m, molar conductivity, is equal to 1000 K by C, where K is the conductivity, C is the concentration of the solution. Let us substitute 1000, okay, K, that is 10 to the power minus 2 divided by C. What is the concentration? 0.1. 0.1. See here, 1000 into 10 to the power 2 is 10, isn't it? It is 1000 by 100, 10. 10 by 0.1, it is 100. Okay, the unit is Simon per centimeter square per mole. Simon centimeter square per mole. This is the unit. So which is the right option? 100 per ohm. Per ohm they have given it as per ohm only. I have changed it into Simon. Simon means per ohm. So the right option is 100 per ohm centimeter square. 100 Simon centimeter square per mole. So this is the right option. Option B is the right one. For this, option B is the right one. So hope that it is clear for you. Okay. So shall we go to the next question? Question number 4 now. Yes, question number 4. Listen. On decreasing the concentration of a solution of an electrolyte, molar conductivity decreases, but there are different options. So I shall tell you one thing. So actually, conductivity, how we can define is, if you place a solution of an electrolyte between two electrodes, each of 1 meter square area, 1 meter square area, each of 1 meter square area, separated by a distance of 1 meter, 1 meter. If you enclose that gap between the two electrodes by the solution of an electrolyte, then what conductance it shows is called conductivity. So the number of ions which are present in this space in between the two electrodes, that is responsible. Can you tell what is the volume of the solution confined between the two electrodes? It is 1 meter cube. 1 meter into 1 meter, 1 meter cube it will be. So if you dilute the solution, same ions which are present in 1 meter cube of the solution, they get distributed in a larger volume. So the number of ions per meter cube of the solution decreases on dilution. Since the number of ions decrease on dilution, conductivity also decreases. So conductivity of a solution decreases on decreasing the concentration. On decreasing the concentration is nothing but on increasing the dilution. So on decreasing the concentration, conductivity of a solution decreases. Understood? Why? Because number of ions present in a meter cube of the solution decrease on dilution. Yes. Another thing. Now you already know the formula. So lambda m, molar conductivity, is equal to 1000 K by C, as I already told you. Correct. Here C is in the denominator. Concentration term is in the denominator. So though conductivity decreases, but this decrease is much more compared to this. So totally what we can say is, since concentration is the denominator, as the concentration decreases, molar conductivity increases. As the concentration decreases, molar conductivity increases. Understood? So like that, molar conductivity increases when you decrease the concentration. And if you reach a stage where we come across infinite dilution, then the molar conductivity will be maximum, and that is called limiting molar conductivity. Okay, so understood what happens exactly? The conductivity decreases, but molar conductivity increases on decreasing the concentration of the solution. See, on decreasing the concentration of a solution of an electron, molar conductivity decreases? No. Both molar conductivity and conductivity decreases? No. Both molar conductivity and conductivity increases? Absolutely no. Molar conductivity increases, but conductivity decreases. Option D is the right answer. Right? So conductivity decreases because the number of ions present in a meter cube of the solution decrease on decreasing the concentration. Molar conductivity increases because in the formula of calculation of molar conductivity, concentration terms are in the denominator. If the concentration decreases, obviously lambda m increases. Hope that it is clear. We will pass on to the next question. Next question. Fifth one, see here. The resistance of 0.1 m weak acid HA in a conductivity cell is 2 into 10 to the power 3 ohms. The cell constant of the cell is 0.78 per centimeter. Unit also is very important. And lambda naught m, that is limiting molar conductivity of acid HA, is 390 Simon centimeter square per mole. pH of the solution is a beautiful question. So many concepts have been put in one. See, what shall we do? So cell constant they are given, isn't it? Cell constant they are given. Am I right? Then they have given the resistance. So let us find out the conductivity of the solution first. Which formula you need? G star is equal to R into K. R into K. G star is equal to R into K. What you have to find out is K is equal to G star by R. K is equal to G star by R. Yeah, what is this star? What is cell constant they are given? 0.78 per centimeter. Cell constant. The unit of cell constant is always inverse of length because it is a length by area divided by resistance. How much they are given? Resistance 2 into 10 to the power 3. 2 into 10 to the power 3. It is ohms. 2 into 10 to the power 3 ohm. Right? Now, simplification will be. I'll do it in this way. You make it as, okay, 0.78 by 2. 0.78 by 2. It is 0.39. Am I right? 0.78 by 2. 0.39. Then 10 to the power 3. When it goes to the numerator, into 10 to the power minus 3. Into 10 to the power minus 3. Don't disturb this. Okay. 10 to the power 3, keep it as it is. When it went to the numerator, it becomes minus 3. Right? Then this 0.78 by 2 is a 0.39. So this is the conductivity. Then from that conductivity, let us pass on to the molar conductivity. Okay. So molar conductivity, lambda m is equal to, again, the unit of this is per ohm per centimeter, isn't it? Per ohm per centimeter. The unit of this, when ohm goes to the numerator per ohm, then this is per centimeter. Now, when it is in per centimeter, then lambda m formula, as we already solved the previous one, 1000 K by C. 1000 K by C. Right? 1000 K by C. That is equal to 1000. Then K is how much? 0.39 into 10 to the power minus 3. 0.39 into 10 to the power minus 3. Minus 3, I shall write here only. 0.39 into 10 to the power minus 3. 1000. Then this 0.39 into 10 to the power minus 3 divided by C. C is the concentration, isn't it? So concentration is a 0.1. Concentration 0.1. See now, 10 to the power minus 3 and 1000 got cancelled. Right? 1000 into 10 to the power minus 3 into 1. Then 0.39 by 0.1, it is 3.9. 3.9. Understood how it is? It is 1000 and the last here it is 10 to the power minus 3. 1000 into 10 to the power minus 3 is 1. It is 1000 by 1000. Then 0.939 remains. 0.39 by 0.1. That is 3.9. 3.9. Okay. This is lambda. Next, what shall we do? We should calculate degree of dissociation. Degree of dissociation. Degree of dissociation. Degree of dissociation alpha. How will you calculate degree of dissociation? Molar conductivity at given concentration lambda m divided by molar conductivity at infinite dilution, that is limiting molar conductivity, lambda naught m. Lambda naught m. Lambda naught m, lambda m we got it 3.9. Lambda m we got it 3.9. We calculated, and lambda naught m they have given it. Lambda naught m they have given it. Okay. So 390. Okay. So lambda naught m of acetic acid is 390. They have given. So 390. Correct. This 390 they have given. 390 they have given it. 3.9 divided by 390. 3.9 by 390 is how much? 3.9 by 390. It is 1 by 100. 1 by 100. Isn't it? So 1 by 100. 1 by 100. Or shall I write 10 to the power minus 2? 1 by 100. Isn't it? 1 by 100. Shall I write 10 to the power minus 2? Okay. 1 by 100 is 10 to the power minus 2. Yes. What we got here? Alpha. Then we want pH. For pH we want hydrogen ion. So for a weak acid, hydrogen ion concentration is equal to C alpha. This is the formula for calculation of the hydrogen ion concentration of a weak acid. C is the degree of this concentration. Then alpha is this one, 10 to the power minus 2. So see how much it is given. Concentration of 0.1. 0.1 into, this is 10 to the power minus 2. 0.1 into 10 to the power minus 2. Isn't it? 0.1 into 10 to the power minus 2 is 10 to the power minus 3. 10 to the power minus 3. Okay. Last one more step remain now. One more step remain. So when you got hydrogen ion concentration, you have to calculate the pH. I shall write it here. pH is equal to minus log to the base 10 of hydrogen ion concentration. That is equal to minus log to the base 10 of hydrogen ion concentration is 10 to the power minus 3. So the answer is 3. Answer is 3. So dear students, I'll explain it once again because so many concepts have been put in one question. So actually, this is the question appeared in last CET. Last CET, this was the question. See, though it is simple, you are supposed to know so many concepts. I shall explain it once again. Resistance of 0.1 molar weak acid HA in a conductivity cell is 2 into 10 to the power 3 ohm. The cell constant is given, lambda m not m is given, pH of the solution they ask. See how many concepts they get. First, what shall we do is, knowing the cell constant and the resistance, find out the conductivity. Conductivity, we got it. 0.78 cell constant divided by 2 into 10 to the power 3. That is 0.39 into 10 to the power minus 3. I wrote it. Then, after knowing the conductivity, we went to the molar conductivity. Molar conductivity, when the conductivity is in Simon per centimeter, it is 1000 K by C. 1000 comes in the numerator. 1000 K is 0.39 into 10 to the power minus 3 by C concentration. 1000 10 to the power minus 3 became 1. So ultimately 0.39 by 0.1, it is 3.9. It became 3.9. Yes, we got the conductivity. Then degree of dissociation. These are all from Color's law. Degree of dissociation you can find by dividing the molar conductivity at given concentration by limiting molar conductivity. Molar conductivity, we calculated it as 3.9. Then limiting molar conductivity, it has already been given as a 390. Correct. So 3.9 by 390, it is 1 by 100 or 10 to the power minus 2. 10 to the power minus 2. Yes. We are approaching the last step. Now, what they have asked is pH. For calculation of the pH, what you need is hydrogen ion concentration. For a weak acid, hydrogen ion concentration is equal to C into alpha, where C is the concentration, alpha is the degree of dissociation. C, they have already given it as 0.1 into alpha, we got it as 10 to the power minus 2, 10 to the power minus 2, then it is 10 to the power minus 3, it became 10 to the power minus 3, hydrogen ion concentration. Now we are approaching the last step. When the hydrogen ion concentration is known to you, to calculate the pH, you require this formula. pH is equal to minus log to the base 10 of hydrogen ion concentration, or that is minus log to the base 10 of 10 to the power minus 3. Log 10 to the power minus 3 is minus 3. Since one negative sign is already there, the answer is 3. So the right option is this. D is the right option. Okay. Hope that it is clear. This is the problem which was asked in last CET examination. Though it is simple. See, dear friends, just see how many concepts have been put in one and the same formula. How many formulae you need? You know the idea of pH, you require the idea of pH, you require the idea of conductivity, you require the idea of molar conductivity, you require the idea of degree of dissociation. Everything they have put it in one formula. But very easy, very easy. Okay, hope that. So let us always prepare for the worst and get the best. Okay, so hope that the problems will be tougher and tougher. If you get the easy problems, it will be very easy. Be happy, solve everything, be happy. So don't think that we will get easy problem, anyway it is CET, don't think like that. Okay, prepare for the worst and get the best. Then you will be a successful person, right? We will go to the next question. Okay, yes. Now, let us go to the next question. Okay, we will go to the next question. So, hope that speed is also You can cooperate with this, isn't it? Can compromise. Yes. Yes, this is limiting, given that limiting molar conductivity of barium hydroxide, barium chloride and ammonium chloride, they have given. What they have asked is limiting. It is a very easy question. It's a very easy question. Okay. Even this type of questions will be asked in will be asked in your board exam also. Board exam also. Now here, this is based on Coller's law. Based on Coller's law. Okay. So there is no hard and fast formula for this. You have to frame a formula. Just see here, what they have asked is, they have asked limiting molar conductivity of ammonium hydroxide. Limiting molar conductivity of ammonium hydroxide, they have asked, is equal to. Okay. Using the limiting molar conductivity of the given electrolyte, you have to use this. Ammonium hydroxide. Ammonium ion is there, hydroxide ion is there. For ammonium ion, which one? It is in this ammonium chloride. Lambda naught of ammonium chloride. NH4Cl. Right? Ammonium ion came. We don't want chloride ion. Let us see what we have to do. Okay. We got the ammonium ion. Then we want OH ion. No. OH ion is in which? OH ion is in barium hydroxide. But one molecule of barium hydroxide contains two OH ions. We want only one. So what we should do is plus half into lambda naught of barium hydroxide. Half into lambda naught of barium hydroxide. You understood why you have to multiply it by half? Because we want only one OH here. Here there are two. We want of only one OH. So you have to multiply it by half. Okay. Then what we don't want? Here we don't want chloride ion. Okay. We don't want chloride ion. Here we don't want. Here we don't want. Which one? Half barium ion we don't want. Half barium ion we don't want. So subtract what? Half the limiting molar conductivity of barium chloride. Subtract half the limiting molar conductivity of barium chloride. See here, ammonium ion we got here. It is there. We don't want chloride. OH we got here. OH1 we got because we have multiplied by half. And then we don't want half of barium ion and one chloride ion. So of this you have to multiply. Now substitute ammonium chloride how much? Ammonium chloride how much here? And ammonium chloride are respectively. Ammonium chloride is 280, isn't it? So 129.8. Last one 129.8. 129.8 plus half of barium hydroxide is how much? The first one is barium hydroxide now. Half of 523.28. 523.28 minus half of barium chloride is how much? Barium chloride is in between. That is half of 280. Half of 280. This you have to do. Okay. Here you can just guess. See here. See here. Half of 129, and it is 280, isn't it? Half of 280. Half of 280 is how much? Almost 140. Half of 280 is almost 140. Half 129, this is 140, almost equal. Then the answer should be half of 523. Right now, the answer should be almost half of 523. Half of 500 is okay, 250. Half of 23 is 10. Something like 260. Answer should be something like 260. Correct now? So I think the first one is the right answer. Like that you can, instead of go on simplifying it, sometimes logic you have to use. Understood? See, this 129.8. Half of 280 is 140, almost. Then this almost same gets cancelled. So your answer should be very near to half of 523. Very near to half of 523. A little less, because what you have to subtract is a little less. So the right answer is 251.44. So even for your board examination, simple problems of this type they will ask. But here you have to multiply it by half, etc. But for board examination, just add 2 and subtract 1, you will get the answer. This is based on Cholera's law. Hope that it is clear. Now, next one. E1, E2 and E3 are the EMF values of the galvanic cells respectively. Okay, 1, 2, 3. They have asked concentration is different. See here now. So one thing I'll tell you. From the cell, you must write the reaction. Right? So I shall tell you one simple trick. Anyone, you write it as 1, second one, third one, fourth one. These are the 4 items involved. Leave the concentration. So if at all you want to write the reaction, odd numbers first. 1, 3, that side even number, 2, 4. 1, 3, 2, 4. Yeah, what is 1, 3? Zn. Yeah, come on. Zn plus 1, 3. Cu plus 2 gives, right, 1, 3. Then that's a 2, 4. 2, 4 means what? Zn plus 2 plus Cu. This is a simple trick to write the reaction if the cell is given. If the reaction is given, to write the cell, same trick. 1, 2, 3, 4. 1, 3, 2, 4. See, 1, 3, 2, 4. Right? The same. For this Daniel cell, E cell is equal to E naught of the cell. After using Nernst equation, E cell is equal to E naught of the cell, which is fixed for this cell, and for this cell it is a 1.10 volt. Okay, minus 0.059 by N, which is 2. N, which is 2. For calculation of the N, what will you do? Any one species you concentrate, zinc. Say for example, there also you concentrate on zinc only. See the difference of the charge. Any atom in its free state has got 0 charge. Here it is a plus 2. So the difference is 2. That's the value of N, 0.059. Log to the base 10 of, in the reaction, which comes in the right side should come in the numerator. In the reaction, which comes in the right side should come in the numerator. And any element in its free states, its activity is assumed 1 and it should be omitted. It should be omitted. You did not show it in the equation. So, log to the base 10 of molar concentration of zinc comes in the numerator. This you have to leave it because it is an element in its free state divided by molar concentration of copper. Correct now? It will be like this. Now, let us see what is E1. E1 is, I shall write here, E1 is E naught, which is fixed, E naught minus 0.059 by 2 log to the base 10 of, yeah, in the first, what is the concentration of zinc ion? It is 1 divided by, what is the concentration of copper ion? That is 0.1. Correct. 1 by 0.1 is 10. Log 10 is 1. Correct. 1 by 0.1 is 10. Log 10 is 1. So what remains here is E naught minus 0.059 by 2. Correct. You understood why it is a? So because, so it is a log 10, it becomes 1 by 0.1 is 10, log 10 is 1, so I have left it. Then come to E2, I shall write E2. E2 is E naught minus 0.059 by 2 log 1 by 1, because this concentration is also 1, this concentration is also 1, but 1 by 1 is 0, so the entire term disappears. 1 by 1 is 1, log 1 is 0. So the entire term disappears. It becomes E naught, because the other term disappears. Similarly, if you work it out, E3 will be E naught minus 0.059 by 2 log. Yeah, concentration of zinc is 0.1 by 1. 0.1 by 1. Log 0.1 by 1 is bar 1. So this gets cancelled. This gets cancelled. So it will be E naught plus 0.059 by 2. You understood how we got this plus? 0.1 by 1. Log of 0.1 is bar 1, 0.0. That minus sign gets cancelled with this minus sign and it becomes plus. Now see here. E1 was E naught minus 0.059 by 2. E2 was E naught. E3 was E1 plus 0.051. Yeah, which one is highest now? Which one is highest? E3 is highest, then comes E2, and the last one is E1. E3 is highest, okay? E3 is highest, then comes E2, and the last one is E1. E1 is the least one, okay? E3 is the highest. Option A is the right one. Option A is the right one here, okay? So E3 is the highest because it is E3 is the highest because it is E naught plus 0.059 by 2. E2 is the next because it is only E naught. E1 will be the least because E naught minus 0.059. So this is the right answer. So hope that it is clear. Yes. We'll move on to that. Next one. The cell, again Daniell cell only. If it is allowed to discharge completely, what they are asking is, what is the ratio of concentration of zinc ion to copper ion? The ratio of concentration of zinc ion to copper ion. See here, again let me write. E cell is equal to E naught of the cell, which is 1.10, minus 0.059 by n, which is 2, log to the base 10 of concentration of zinc ion comes in the numerator divided by copper ion comes in the denominator. In the net reaction, what appears in the right side, you must write it, is it? Now, when the cell is discharged completely, which becomes 0? E cell becomes 0. When the cell is discharged completely, E cell becomes 0. E cell becomes 0. When E cell becomes 0, we will put that to this side. So 0.059 by 2 log to the base 10 of zinc ion to copper ion. Okay, so if you are bringing it to this side, will be E naught, which is 1.1. Okay, therefore log to the base 10 of zinc ion to copper ion, is equal to, I want only this, E naught is 1.1 into 2 divided by 0.059. Okay, 1.1, which is the standard value, E naught for Daniell cell, into 2, it comes here, and divided by 0.05. If you work it out, it will be almost 2.2 by 0.06. You make it like this. Instead of 0.059, you make it 0.06, 2.2 by 0.1. So that is roughly 37. Now log anti-log relationship, I shall tell you. Log anti-log relationship. So 10 to the power 0, log of that is 0. Log 1 is 0. 10 to the power 1, log 10 to the power 1 is 1. So if you take the anti-log of 0 is 1. Anti-log of 1 is 10 to the power 1. Anti-log of 1 is 10 to the power 1. Now I want the anti-log of 37 because I don't want here log. Therefore, zinc ion to copper ion. Yeah. See here, Antilog of 0 is 10 to the power 0. Antilog of 1 is 10 to the power 1. Antilog of 37 is almost 10 to the power 37. It should come like this. See now, compare. 37.3 is not the answer. It is 10 to the power 37. Antilog you have to take because we don't want the log here. So if you take the antilog, it will be 10 to the power 37.3. Option B is the right one. So option B is the right one. Okay. Hope that it is clear. When the cell is discharged completely, E cell becomes 0. E cell becomes 0. Then you have to do like that. Okay. We will move on to the next question. Next question. Yes. The solution of copper sulfate in which copper rod is immersed is diluted to 10 times. So it is Nernst equation for single electrode. For copper electrode, Nernst equation is E of copper electrode is equal to E naught of copper electrode, I shall write like this only, minus 0.059 by N, which is 2 log to the base 10 of 1 by copper ion. This is what I have written is Nernst equation for single electrode, copper electrode. Okay. Now what they are doing is they are diluting the concentration to 1/10. When concentration of copper ion is 1 m, take for example 1 m, E1 is equal to, okay, so when the concentration of copper is 1 m, 1 by 1 is 1, log 1 is 0, entire term disappears, E1 will be equal to E naught of the cell. E1 will be equal to how much? E naught of the cell. Okay, when it is diluted, to 1/10, E2, let it be the new electrode potential, E1, E naught minus 0.059 by 2 log diluted to 10 times, means 1 by copper ion concentration will be 1 by 10. 1 by 1 by 10 is 10. 1 by 1 by 10 is 10. Log 10 is 1. I can write it as E naught minus 0.059 by 2. Okay, because 1 by 1 by 10 is 10. Log 10 is 1. So it is removed. Or roughly it is E naught minus, if it is taken as 0.059, okay, you take it as 0.03. Okay, so initially if it is E naught of the cell, after diluting it becomes E naught minus 0.03. E naught minus 0.03. Initially before diluting it was E naught. After diluting it became E naught minus 0.03. So what is the right answer is increased by no, decreases by yes. So this is the answer. Decreases by 0.03 volt. Decreases by 0.03 volt. Okay, not 0.09 because n value is 2. N value is 2. Decreases by 0.03 volt. 0.03 volt. So that is the right one. Yes. Next. See here. Given hydrogen electrode, it is hydrogen electrode, its electrode potential is 0. Yes, see here. Generally, hydrogen electrode is a reference electrode. Its potential is taken as 0. It is dipped in 1 molar HCl, a solution containing 1 molar hydrogen ion. What they have done is, they have dipped it in water. In spite of that, they want its electrode potential 0 only. So what they have asked is, at what pressure if you pass hydrogen, this also shows the potential of 0 volt. Now let me write the reduction reaction in the hydrogen electrode. 2H plus 2 electron, reduction means gain of electron, gives H2 gas. This is the reduction reaction taking place in hydrogen electrode. Now I can write like this, E of hydrogen electrode, E of hydrogen electrode is equal to E naught of hydrogen electrode, E naught of hydrogen electrode, okay, minus 0.059 by n is 2, this 2. Then what comes in the right side should appear in the numerator. Log to the base 10 of partial pressure of hydrogen, divided by hydrogen ion square. This is the equation what we got. Okay, so E naught, E of hydrogen electrode, E naught of hydrogen electrode minus 0.059 by 2 log to the base 10 of, this is hydrogen gas, partial pressure of hydrogen divided by this. So this is 0 because it is a reference electrode. Electrode potential of hydrogen electrode is 0. This also they want 0. For this to be 0, this should be 0. Okay, their question is, this is anyway 0. It is reference electrode. They want this also to be 0. For this to be 0, this should be 0. If this entire term is 0, then this will be 0. Now in this, how can it be 0? This ratio is 1. If this ratio is 1, log 1 will 0. Obviously, the entire term disappears. So you get this. What is that ratio? So, partial pressure of hydrogen should be equal to hydrogen ion square. If this is true, then this ratio becomes 1. When this ratio becomes 1, log 1 will be 0. So the entire term will be 0. Then this will be 0 because anyway this is 0. Now what does this say? Hydrogen ion concentration in water, you know, ionic product of water, hydrogen ion into hydroxide ion is 10 to the power minus 14. So hydrogen ion concentration is a root of 10 to the power minus 14, that is 10 to the power minus 7. Correct now? This is the concentration of hydrogen ion in pure water. What they have taken? Pure water. This you have to substitute there. Therefore, partial pressure of hydrogen should be hydrogen ion concentration 10 to the power minus 7 of that square 10 to the power minus 14 atmosphere. So if the pressure of hydrogen is 10 to the power minus 14 atmosphere, though it is dipped in water, this hydrogen electrode will give the potential of 0 volt. That is the meaning. Okay, so what is the right answer now? It is 10 to the power minus 14 atmosphere. Option D is the right one. 10 to the power minus 14. Okay, I will explain it once again. See here, a little tough. So this is the hydrogen electrode reduction reaction. Then I can write the electrode potential. For that, E of hydrogen electrode, E naught of hydrogen electrode minus 0.059 by 2 log to the base 10 of partial pressure of hydrogen divided by hydrogen ion square. This is anyway 0. They want this also to be 0. That means this entire term should be 0. For this entire term should be 0, only possibility is this ratio should be 1. When this ratio is 1, log 1 will be 0. So this ratio to be 1, this should be equal. Partial pressure of hydrogen should be molar concentration of hydrogen ion square. In water, you know, ionic product of water, the product of hydrogen and hydroxide ion is 10 to the power minus 14, and both are equal in water because water is neutral. So each one concentration is 10 to the power minus 7. That if you substitute, the partial pressure of hydrogen should be 10 to the power minus 7 of that square, 10 to the power minus 14 atmosphere. This is the right option. Okay, so this question. We will move on to the next question. EMF of the cell, nickel, and then another is gold, isn't it? Another is gold. There it is here. Okay, then the SRP they have given of both the electrodes, they have asked. Even this type of problems may be asked for your board exam also. We will find E naught of the cell. E, I shall write our board work from here only. E naught of the cell is equal to E naught of cathode minus E naught of anode. E naught of anode. This is the formula. Out of two SRPs, gold they are given 1.5 volt, nickel they are given minus 0.25. Considering the sign which has got higher value, that is cathode. Considering the sign, plus means plus, minus means minus. Considering the sign which has got higher value, that is the cathode. So one is 1.5, another is minus 0.25. So with this is higher, so this is a cathode. So E naught of gold, AU I shall write, minus E naught of nickel. This is how we have to find. Higher value minus lower value. That is, this value is how much? 1.5 minus of minus 0.25. How much it will be? It will be 1.75 volt. This is E naught, 1.75 volt. This is how we have to find the E naught. Higher value minus lower value. Okay, E naught cannot be positive, negative, sorry. E naught should not be negative. E naught's electrode potential will be negative or positive, but E naught of the cell, it is always positive, 1%. Now, again, let me write the equation, the tactics 1, 3, 2, 4. First item is which one? Nickel. One is nickel. Okay, nickel. Third item is what? Third item is a nickel. Then third item is a Au plus 3. Au plus 3 gives. Then 2. 2 is which one? Ni2 plus. Ni2 plus next is which one? Au. Okay. You are written 1, 3, 2, 4. Then the equation is to be balanced atom-wise, charge-wise. That's very important. Here a little finishing is required for balancing it. Au plus 3, Ni plus 2. So where it is 2, you have to multiply by 3. Where it is 3, you have to multiply it by 2. Correct? So 2 into 3 is 6, 3 into 2 is 6. Now, since 3 Ni, obviously here will be 3. Okay, obviously it will be 3. Then here 2 Au, it is 2. Obviously it is 2. Okay. So Ni, 3 Ni, 3 Ni, 3 Ni you have tried. Then 2 Au, 2 Au. Now how can I write it? E cell is equal to E naught of the cell. We have already calculated. E naught of the cell minus 0.059 by n log to the base 10 of, yeah, which one is in the right side? Nickel plus 2 of that cube. Correct? Nickel plus 2 of that cube. The number of moles appear in the as a power divided by then gold plus 3 of that square. Now I shall tell you how to find out the value of n. So for calculating n, you try to stick on to anyone. Okay, nickel, fine. Total 3 Ni. What is the charge? 0. Because any atom in its free state has got 0. Then 3 Ni plus 2. Full 3 into 2. How much it is? 3 into 2, 6. Here it is 0. So the difference is 6. The value of n is here 6. E naught we have already calculated, 1.75 minus 0.059 by 6. You understood how it is 6? You should not find for each ion totally how many ions are involved. Even if you take gold, same thing. 3 into 2, 6. Here it is 0. Difference is 6. That is how you find the value of n. Log. Then what is nickel ion concentration? Nickel ion concentration is how much? It is 1. 1 cube. Nickel ion 1 cube. Okay. Gold ion concentration how much? It is 0.01. 0.001. Is it? 0.001 m of that square. See here. 1 cube will leave it 1 only. This is 10 to the power minus 3. 10 to the power minus 3 square is 10 to the power minus 6. When it goes to the numerator, 10 to the power 6. So log 10 to the power 6 is 6. That 6 gets cancelled with this 6. I tell it again. 1 cube anyway 1 only. 0.001 is 10 to the power minus 3. 10 to the power minus 3 cube, 10 to the power minus 6. When it comes to the numerator, it becomes 10 to the power 6. Log 10 to the power 6 is 6. So that 6 gets cancelled with this 6. So the value will be 1.75, sorry, 1.75 minus 0.059. Correct? 1.75 minus 0.059, because this 6 gets cancelled with that 6 here. Log 10 to the power 6, it will be 6, that cancelled. So what is the right answer now? So you take it as 0.06. 1.75 minus 0.06. 0.06. It is 5 means 59. So this is a 1.69. So what is the answer? 1.69. So anyway, we went to the next question. So 1.69 was the answer. Correct? 1.69 was the answer. Right? Yes. We will move on to the next question. Okay. Yes. See, standard EMF of the galvanic cell involving 2 moles of electrons in its redox reaction is 0.59 volt. The equilibrium constant for the redox reaction of the cell is, see, the relationship is E naught of the cell is equal to 0.059 by N log to the base 10 of equilibrium constant. This is the relation. E naught of the cell 0.059 log to the base by N log to the base 10 of equilibrium constant. Standard EMF of galvanic cell involving, okay, they are given redox reaction, that is 0.59. So I want what I asked. So the equilibrium constant. Therefore, log K is how much? Log K, we will rearrange. Log K is equal to E naught of the cell into N by 0.059. Correct? We want log K, E naught of the cell into N by 0.059. E naught of the cell is 0.59 into N is involving 2 moles of electron. That is N divided by 0.059. This is as it is. See here, quite simple. 0.059, 0.59. 1s are 10s are 10 into 2, 20. 10 into 2, 20. So what I want is now, don't want this log. So to remove this log, what shall we do? Take the antilog. What is the antilog of 20? As I told you many times, antilog of 20 is 10 to the power 20. This is the right answer. Antilog of 20 is 10 to the power 20. That's the answer. Okay. Understood? Yes. We will move on to the next question now. Next question. For the cell reaction, right? They are given this. E naught of the cell they are given. Standard Gibbs energy. So Gibbs energy delta R G naught of the is equal to minus N F E naught of the cell. This is the formula. Delta R G naught, standard Gibbs energy, minus N F E naught of the cell. Now let us substitute. Yes. N is, as I told you, you concentrate on any item. Let me take 2Fe3. What is the total charge? 2Fe each 3 plus. 2 into 3, 6. Here Fe is there in the form of 2 plus. 2Fe2 plus 4. There it was 6. Here it is 4. What is the difference? That is 2. That's the value of N. Understood? 2 into 3, 6. 2 into 2, 4. Difference between 6 and 4, it is 2. Or even if you take this thing also same. 2 into minus 1, minus 2. There it is 0. So it is 2. I taken this. F is 96,500. Actually, it is 96,487. But you can approximate it to 96,500. That's 1 Faraday. E naught of the cell, how much they are given? E naught of the cell, 0.24. 0.24. E naught of the cell is 0.24. This what you are getting will be in terms of Joule. This will be in terms of Joule. But the answers are in kilojoules. Answers are in kilojoule. How do you convert joule into kilojoule? Divide by 1000. Divide by 1000. You understood why I have divided by 1000? Answers are given in kilojoule. What you are getting here will be in joule. So if at all I want it in kilojoule, you have to divide the answer in joule by 1000. See here, now see. 1000, okay, you can, 1000, you can here, 96.5. 96.5, you take it as almost 100. 96.5, you take it as almost 100. 100 into 0.24, 24. Correct. 24 into 2, almost minus 48 something, isn't it? Minus 48. That's how you have to do the approximation. So what I did is denominator 1000. So I assumed a decimal point here. Decimal point here. After that decimal point here, it became 96.5. You take it as 100. 100 into 0.24 is 24. 24 into 2 is 48. Minus 48. The answer which is very near to minus 48, it is option A. Option A, that is the right answer. Minus 46.32 kilojoule. Minus 46.32 kilojoule. Okay, this is how we have to solve it. So we will move on to the next slide now. Next slide. If hydrogen electrode in two solutions, pH 3 and pH 6, are connected by a salt bridge, the EMF of the resulting cell is same hydrogen electrode. One they have dipped it in pH 6, another they have dipped it in pH 3, and both have been connected using a salt bridge. What they have asked is, what is the EMF of the cell? What they here, one thing I'll tell you. Electrode potential of hydrogen electrode, not standard, any condition. Electrode potential of hydrogen electrode is minus 0.059 into pH. This is the formula. Even in your board exam, they ask a problem on this. Okay, so electrode potential of hydrogen electrode, okay, it is a minus 0.059 into pH. Now the two solutions. One is pH 6, right? Another is a pH 3. This also hydrogen. One is pH 3, another is pH 6. What is the electrode potential of this? Electrode potential E1, that is minus 0.059 into 6. Correct now? Because that is the general formula, minus 0.059 into pH. What is the electrode potential of this hydrogen electrode? Minus 0.059 into 3. So these are the electrode potentials of these two hydrogen electrodes. Now just see, which one is lower value and which one is higher. This is minus 0.059 into 6. This is minus 0.059 into 3. Right? Which one has higher value and which one is smaller value? Yeah, this is smaller value, isn't it? This is anode. Anode. This is higher value. This is cathode. Anode minus cathode. Correct? Because it is really higher. Now, E cell is equal to E of cathode minus E of anode. This is the formula, isn't it? That is minus 0.059 into 3, minus 0.059 into 3, minus of minus 0.059 into 6. Correct now? This is minus 0.059 into 3. Higher value is this. Minus 0.059 into 6. This will be lower value. Minus becomes plus. Minus becomes plus. So I can take, okay, I can take, so this I shall take first 0.059 into 6, because minus became plus, minus 0.059 into 3. This minus remained as it was. This became plus. What shall I do? I'll continue it here. I'll take 0.059 as the common factor. 0.059 as the common factor. 0.059 I taken 0.059 as a common factor. Okay, from this into 6 minus 3. Am I right? From these two terms, what I did is I took 0.059 as a common factor, then into bracket 6 minus 3, which is 6. That is 0.059 into 3. 0.059 into 3. You take it as 0.06 roughly. 0.06 into 3 is 0.18. 0.18 plus 0.18, which is the answer very near to plus 0.18. Right? Option A is correct. Isn't it? 0.177. That is the correct one. You understood? See, briefly I'll tell it again. Electrode potential of hydrogen electrode is minus 0.059 into pH. This is the formula. They have taken two hydrogen electrodes. One has been dipped in a pH 3, another for pH 6. Let me calculate the electrode potential in pH 6. Minus 0.059 into 6. Let me calculate electrode potential in pH 3. Minus 0.059 into 3. Out of these two, is it not minus sign is there? Is it not higher value? Minus 0.059 into 3 is higher. Minus 0.059 into 6 is lower. So E cell is equal to E cathode minus E anode. This becomes, higher value becomes cathode. This is anode. Minus 0.059 into 3. Minus of minus 0.059 into 6. This became plus. Then what I did, from these two, I took 0.059 as a common factor. Then inside the bracket 6 minus 3 remains. 0.059 into 6. It is very near to 0.18. This is the right answer. 0.177 volt. Hope that it is clear. We will move on to the next slide one. Yes, see here. SRP of zinc, okay, nickel, iron, and this there, values there. This is the reaction. From this reaction, can you identify which is oxidized and which is reduced? Which is oxidized and which is reduced? X became plus 2. Is it not oxidation? X became plus 2. Increase in oxidation number is oxidation. So, where the oxidation takes place, it is anode. Where the oxidation takes place, it is anode. Y plus 2 became Y. Has it not gained electron? Gaining the electron means reduction. Reduction. That which undergoes reduction is the cathode. That which undergoes reduction is the cathode. Correct? That is what we can make out from this formula. Now, we know E cell is equal to E of cathode minus E of anode. Isn't it? E of cathode minus E of anode. Cathode is which here? Cathode is which? Cathode is E of Y. Cathode is this one minus E of X. Correct now? Anode is X. Where the oxidation has taken place, that is anode. Y minus N. For this to be spontaneous, for the reaction to be spontaneous, okay, E cell should be positive. E cell should be positive. Why? Because delta G naught is equal to minus NF E naught. When E cell is positive, then only the delta G will be minus. For a reaction to be spontaneous, delta G should be negative. For E cell is always positive. For this, E cell should be positive. For E cell should be positive, whatever you have to subtract should be the least value. Okay? X1 least, X least, least value. X1 least, I mean lowest. Correct now? X1 should be lowest. Right? E cell of the positive. X1 should be least. Okay? Y minus X. Y minus X. X1 should be least. Okay? Y highest. Y highest. X1 is the least. Which is the least value here? They are given the values. One is how much? One value is how much? Minus 0.76. Minus 0.23. Minus 0.44. Okay, out of this, which is least? Which is the lowest one? Which is the lowest one? Is it not minus 0.76? minus 0.76 is the lowest one. So X1 should be the lowest one. That means X1 should be zinc. X1 should be zinc. Okay, X1 should be zinc. Which one is then? X1 is zinc, lowest value. What you have to subtract should be the least value. When you the one which you are going to subtract is the least value, then only this will be positive. Then only the cell reaction will be spontaneous. So that should be the least value. X least value. X should be zinc. X should be zinc. Option C is correct. Option C is correct. Okay. X is the least value, that is zinc, minus 0.76. Minus of minus 0.76 becomes plus. Then whatever may be the value of Y, the E cell becomes positive. The reaction will be spontaneous. The reaction will be spontaneous. So option C is the right one. Okay. We will go to the next one. Next slide, please. Yes. Given the cell reaction, see here, this is a less. What they are speaking? Solubility. Solubility. Solubility means solubility product. I shall write two formulas. For this salt, Mx, how does it ionize? M plus X minus. Correct now? It ionizes like this. Then Ksp, solubility product, is the product of molar concentration of the ions. That is M plus into X minus. This is the expression for solubility. For information, I'll keep it aside. Then this is AB type salt. Mx is AB type salt. For this, solubility is equal to root of Ksp. For AB type salt, because what they have asked is the solubility. So solubility is square root of solubility product. We'll try to find out the solubility product. Then we will go to that. Now I want this equation. See here. I want this equation. From these two equations, as we used to do it in thermochemistry, Mx I want it in the right side. We have it in the right side. M plus I want it to the left side. M plus I want it to the left side. X minus anyway it is there in the left side. So shall I do 1 minus 2? Equation 1 minus 2. Equation 1 minus 2. Equation 1 minus 2 if I do Mx 1 minus 2, electron gets cancelled, mm gets cancelled, this becomes minus, gives M plus X minus. Is it not the same we are getting? 1 minus 2. This also will do the same thing. 1 minus 2. 1 minus 2. I shall work it out here. 0.799 minus 0.799 plus 0.207. How much you got? 2. This is a 9, 5 minus 0.599. So E naught is equal to minus how much you got there? Minus 0.592. 592 volt. Minus 0.592 volt. Okay. Now for this, let us write an expression for the E cell. Okay. Yeah, when the cell is discharged completely, once again I am telling, for this how can you write? E cell is equal to E naught of the cell minus 0.059 by n. N is 1 log M plus into X minus. I can write like this because this is solid. You leave it. Solid, you leave. When the cell is discharged completely, which becomes 0? E cell becomes 0. E cell becomes 0. Then how can I write? When E cell becomes 0, 0.059 log M plus into X minus. 0.059 log m plus is equal to E naught of the cell. What we got it as a minus 0.0592. You understood it? When the cell is discharged completely, E cell becomes 0. Then E naught of the cell becomes 0.059 log. Okay. So this value we already know it. This value we already know. Right? So what we want is log. Therefore, I shall put it as log m plus into x minus. Log m plus into x minus. Right? I want this. So minus 0.059 by minus 0.059 by sorry, E naught is equal to this is not 0 is not there, minus 0.59 this 0 is not there by 0.059 minus 0.59 this is 0.59 we got it divided by 0.059. Is it not minus 10? Minus 0.59 by 0.059. Is it not minus 10? So log KSP is equal to minus 10. I shall write here log KSP is equal to minus 10. Log KSP is equal to minus 10. So KSP is how much? Log KSP minus 10. So KSP is equal to antilog of minus 10, 10 to the power minus 10. Right? KSP, how much you got it as a 10 to the power minus 10. Then what is S? Solubility. Solubility is root of 10 to the power minus 10. So root of 10 to the power minus 10. The answer is 10 to the power minus 5. 10 to the power minus 5. 1 into 10 to the power minus 5. Option D is the right. Yes. The students, I'll explain it again. These are the two equations given now. Since they are mentioned about the solubility, we will write an expression for the solubility. This Savita ionizes. KSP you can write like this. Since it is AB type salt, solubility is root of solubility product. Okay. When you subtract the second equation from first one, equation number 1 minus 2. Equation number 1 minus 2, you get this. 1 minus 2, you get this. Then you can write E cell for this. E naught of the cell minus 0.059 log to the base 10 of product of the species which are there on the right side. Then when the cell is discharged completely, this becomes 0. When this becomes 0, these two will be equal. Okay. So when that becomes 0, these two will be equal. Right? Then what I did, log this m plus into x minus is equal to minus 0.59 divided by 0.059. Minus 0.59 divided by 0.059. Minus 10. So I want now this solubility product. So I have to find the antilog of that. So antilog of minus 10 is 10 to the power minus 10, which is the solubility product. I want solubility. Solubility is root of 10 to the power minus 10, that is 10 to the power minus 5. So this is the right answer. 1 into 10 to the power minus 5. Yes. Next question is the EMF of the cell. See here. When a cell is represented, whatever is there to the right side, whatever is there to the right side, I mean whatever is written first, that is the anode. This is the anode. In a cell, the first is a anode. Okay. The next comes a cathode. Next comes cathode. In a cell, always anode is written first to the left side, cathode is written next, I mean to the right side. Okay. Let me write the anodic reaction. Anodic reaction. Which reaction takes place at the anode? Where the oxidation takes place, it is anode. Oxidation takes place. Anode oxidation takes place. So oxidation means what? Oxidation means loss of electron. Oxidation means loss of electron. Two chloride ions, right, lose 2 electrons. 2 chloride ions, lose 2 electrons, and give chlorine gas. Give chlorine gas, right? Anode is this chlorine gas at partial pressure 1. Chlorine gas at partial pressure P1. Cathodic reaction. Cathodic reaction. Cathode means reduction. Reduction. It is chlorine gas at a pressure of P2. Here they are given P2. Gives 2 chloride ions and 2 electrons. So cathode means, so it is oxidation means loss of electron. Cathode means gain of electron, So this chlorine gains 2 electron. Chlorine gains 2 electron, gives 2 chloride ions. So the overall reaction, how can you write it? Chloride ion gets cancelled. So loss of electron, gain of electron gets cancelled. So what remains is chlorine from pressure P2, is changed to chlorine from pressure P1. That is the net reaction, overall reaction. Chlorine from pressure P2, this one, is changed to chlorine pressure P1. So for this, E cell is equal to E naught of the cell anyway for 0 minus 0.059 by 2, I can write, log to the base 10 of partial P1 by P2. If I am not happy with the minus sign, I can equally write it as plus 0.059 by 2 log P2 by P1. What I did is, here negative sign, I substituted by plus and I have interchanged this. So what they are asking is, for this to be positive, P1 by P2 should be greater than 1, because log of a number greater than 1 is positive. So for E cell to be positive, what? P2 should be greater than P1. P2 should be greater than P1. If P2 is greater than P1, this number will be greater than 1. So log of a number greater than 1 is positive. So this positive sign remains. So which is the right answer? P2 should be greater than P1. P2 should be greater than P1. Option B, P2 should be greater than P1. Okay, hope that it is clear. Even for hydrogen electrode also they have asked like this. Now let me go to the next question. Okay, so very easy. Next question. The cell potential of a given electrochemical cell is 1.8 on the value of X is. Again, let me write the reaction here. So this is the cell. Reaction is 1, okay, plus 3 gives 2 plus, right now 1 3 2 4, that formula 1 3 2 4, right? How will you write E cell? E cell is equal to E naught of the cell minus 0.059 by n log mg plus 2 divided by Fe plus 2. Because here 2 electrons, so no problem. What they have given there? The potential of given electrochemical cell is 1.861. 1.861 is equal to E naught of the cell. How will you calculate? E naught of the cell, higher value minus lower value. E naught of the cell, higher value is minus 0.45. Lower value is minus of minus 2.37. Minus 2.37. Okay. Minus 2.37. Minus of minus 2. It is 2.37. I shall write here 2.37 minus 0.45. It is 2. Okay. Then 13 minus 4, 9. Right? 4, 9. Is it not 1? Yes. 1.92. 1.92. 1.86. This is a 1.92. 2.37 minus 0.45. 7 minus 5, 2. Then it is 13 minus 4, 9. 9. Okay, what remains is 1.92 minus 0.059 by 2 log mg plus 2 by fe plus 2. Plus 2. Yes. Okay. Now, let me bring this to this side. So, therefore, 0.059 by 2 log mg plus 2 by fe plus 3. This one is equal to 1.92 minus 1.861. 1.92 minus 1.861. Isn't it? How much it will be? 1.92. Yes, 1 to 12, 6. Yes, it is a 1.92 minus 86. Is it 0.06? 0.06. 0.9 to 1 to 12, 880. 0.0. Okay. 0.0 is 2. Right? So I want now, log mg plus 2 by fe plus 2 is equal to 0.16, 0.06 into 2 by 0.059. 0.059. They are same, isn't it? They are almost same. Right? They are almost same. So it is 112. 2. Right? So I want anti-log. So what is the concentration? What is the concentration? Therefore, mg plus 2 by fe plus 2 is equal to anti-log of 2. 10 to the power 2. 100. Out of this, what they are given? What they are given? Fe plus 2, they are given 0.01. So mg plus 2. Therefore, Fe plus 2 is equal to Fe plus 2 is equal to Fe plus 2 they are given, Fe plus 2 they are given, mg plus 2 is equal to Fe plus 2 is 0.01 into 10 to the power 2, which is 100. So 1 molar. So 1 molar. This is the right. Even this type of problems are possible even for your board exam. Okay. During all these years, they used to ask problems regarding the finding out of E of the cell. But this time in the model question paper, they are given one to find out the concentration. This is how you have to work it out. Okay. Yes, dear students. So hope that all the concepts are very clear. So once again, you have to try them independently. Try them independently and see whether you are getting the same answers. Okay. So don't simply read or by heart. Try to understand the concept. Okay. We will move on to question number 19. So it is an important question of the same type they have asked many times. Now what is here? They have given the electrode potential of 2 electrodes, and of this they have asked. Remember, my dear friends, E cell or electrode potentials, they are not intensive properties. They are not extensive properties. They are intensive properties. But Free energy is an extensive property. You can add free energy. So what shall we do is, we will convert it into free energy, then we'll do. So what is the first one? M plus 7. M plus 7. M plus 7. They are converting it into M plus 2. M plus 7, M plus 2. Can you tell how many electrons you have to add? Each electron is minus 1. Here 7 plus. The charge went 2 plus 2. So how many electrons you have to add? 5 electrons. Because each electron is minus 1. So 7 plus minus 5 plus 2. The formula I shall write here. Delta G is equal to minus NFE. This is the formula. So of this, how much they are given? Let me write it as E1. Let me write it as E1. 1.5 volt. 1.5 volt. This one. Now we will find out delta RG1. Delta RG1. Same formula. Minus N is how much? 5. F, let me keep it as it is. E, 1.5 we will write. Okay, what I have done? N I have substituted 5, minus sign, it is there in the formula. F as it is. So it became minus 5 into 1.5, 7.5 F. Let it be 1. Equation number 1. Do the same thing. What you did for equation number 1, you did the same thing for 2. M4 plus M2 plus. M plus 4 gives M2 plus. Is it not? 4 plus 2 plus. Now tell me, how many electrons? 2 electrons. 2 electrons. Right? E2, how much they are given? E2, 1.2 volt. So let me find G2. Delta G2. Delta G2. Same formula. Minus 1.2 is into 2. 2 into F into 1.2. It is minus 2.4 F. Let it be 2. Minus 2.4 F. Then what they asked? This one they asked, isn't it? M7 plus gives M, how much? 4 plus. Yeah, tell me how many electrons you have to add? 7 plus 4 plus 5, 6, 7. 3 electrons. 3 electrons. Right now, let it be E3. Let it be E3. What you have to find out is E3. Then G3, let me write it as delta G3 minus electron is 3. Then F we don't want to substitute. You write it as E3. It is number 3. Number 3. Now see here. How to get this equation from these two? How to get this equation from this? So this is the required one now. 7, 4. Plus 7 is here. It is in the right side, left side only. Plus 4 should go to the right side. Plus 4 should go to the right side. So what I can do is equation number 1 minus 2. Equation number 1 minus 2. So if you subtract second equation from first equation, you get this. So delta G3 is equal to delta G1 minus delta G2. Equation 1 minus 2, you get the third one. So also equation 1 minus 2, you get the third one. So delta G3 is equal to delta G1 minus delta G2. Delta G3, what shall I put? Minus 3FE3 is equal to delta G1 is how much? Delta G1, how much you got? Minus 7.5F. 7.5F. Minus of minus. Minus of minus 2.4F. 2.4F. That is equal to, right? So minus of minus plus 7.5 plus 2.4 minus 5.1F. Minus 5.1F, right? Minus 3F E0, E3 is equal to minus 5.1F. Let me cancel minus sign of both the side. Then let me cancel F of both the side. So E3 is equal to, yeah, come on, 5.1 divided by, is it not 3? E3 is equal to, minus minus gone, 5.1 divided by this 3. 5.1 divided by 1.7. This is the answer. 1.7 volt. 1.7 volt. Option D is the right one. So believe it, this was the question asked in CET only, but a couple of years back. This was the question. So what you have to do is, you have to convert it into free energy, and then you can manipulate it as and when you require it, right? So don't add this or don't subtract this. Different number of electrons involved are different. If the number of electrons involved are same, you can do like that, add or that. So otherwise, simply convert it into free energy and then add or subtract to get the equation what you need it. You understood? This is the question. Yes. Next one. It is based on Faraday's laws of electrolysis. Faraday's first law is based on. Here, what they asked is, time in seconds required for the deposition of all the silver present in 125 milliliter of 1 mAgNO3. They have taken 125 milliliter of 1 molar AgNO3 solution. They are electrolyzing it, and they are passing the current of 241.25 amps. And what they have asked is, how much time it needs to remove all the silver present in that. Right. One is, we will find out the number of moles of silver ion. To find out the number of moles in a solution, number of moles of Ag plus in the solution. That is molarity into volume of solution in liter. This is the formula. To find out the number of moles in a solution, what you have to do? To molarity, you multiply it by volume of the solution in liter. Molarity is how much? Present in 1 m. Then how much it is? 125 ml. 125 by 1000. You understood why I divided by 1000? Milliliter, I want to convert it to liter. So it is 0.125 mole. 0.125 mole. So this is the number of moles of silver ion present in the solution. Now, silver ion is reduced by 1 mole of electron, you get silver. Right. 1 mole of this require 1 Faraday, 96,500 coulombs. To reduce 1 mole of silver ion, since the valence is 1, you require 1 Faraday, that is 96,500 coulombs. Therefore, what we want is 0.125 mole. How much you need? 0.125 into 96,500. So much of charge you require. This is Q. Q is equal to IT. Quantity of electric current is current strength in ampere into time in second. This much charge you need. What they have asked is T. Therefore, I shall write here. Therefore, T is equal to Q by I. T is equal to Q by I. Q is how much? 0.125 by 96,500 divided by I, current strength in ampere, 241.25. 241.25. This you have to solve. 241.2. Now we will do it in this way. This you divide by 100, 2 is 0 if you remove. This you, or else, this you divide by 1000. This you multiply by 1000. 125. Right? If you multiply by 1000, 125. If you divide by 1000, 96.5. Then this you keep as it is, 241. Approximation is very important. Approximation. So you understood what I did? I multiplied this by 1000. So should not do any justification to the value. Immediately I divided this by 1000. This multiplied by 1000, 125. This divided by 1000, 96.5. This you keep it as it is. Almost 1 za, 2 za. Is it not? Almost 1 za, 2 za. Right now, 96.5, you take it as 100. 100 by 2, that is 50. This is the right answer. 50 is the right answer. So, you require 50 seconds to remove all the silver present in 125 ml of 1 molar silver nitrate solution using a current of 241.25 amperes. This is how you have to solve. Okay, so you should not go on multiplying or go on dividing. Approximation is very important in CET. Approximate it and try to get the correct answer. Right? Yes. Next one. Again, it is based on Faraday's law only. How long should water be electrolyzed? By passing through 100 amperes of current, so that oxygen release can completely burn 26.66 gram of diborane. This is a little higher level question, but asked in your not CET, a little higher. Okay, JEE exam question it is. What they have done is, they have taken diborane. What is the formula of diborane? B2H6 diborane. They have given the atomic mass of boron 10.8 and hydrogen you are supposed to know it. If you find out the molar mass, it will be 27.6 only. If you find the molar mass of B2H6, it will be something like 27.6. So 27.66 gram of B2O3, B2H6 is 1 mole. That is 1 mole. That's one thing. You must know to calculate the molar mass, and they have taken 27.66 gram of diborane 1 mole. Diborane, how it burns? B2O3, B2H6 plus O2. Boron is converted to B2O3. Hydrogen is converted to water. To balance it, 3H26, B2. Oxygen, 3 plus 3, 6. So 3 moles. So 1 mole requires 3 moles. 1 mole requires how many moles? 3 moles of oxygen. 1 mole of diborane requires 3 moles of oxygen gas for complete combustion. For complete combustion. Now let me go to electrolysis of water. Electrolysis of water. Water, it gives O2 2 you want, 4H plus 4 electrons. This is how you can write the oxidation of water. Oxidation of water you can write like this. H2O gives O2, H plus electrons. Since O2 you want, I have written 2H2. Obviously 4 hydrogen ions. Then charge wise also it is to be balanced, 4 electrons. 4 electron means 4 Faradays. 4 electron means 1 electron means 1 Faraday. 4 mole of electron means 4 Faraday. That is 4 into 96,500 coulombs of charge. For 1 mole of oxygen to be liberated, you require 4 Faraday. But here how many moles we want? For 3 moles. Therefore, for 3 moles of oxygen. 3 moles of oxygen. How much you need? 3 into 4 into 96,500 coulombs. Right now, for 1 mole, 4 into 96,500. But here we want 3 moles. So many Faradays you require. This is equal to Q, which is equal to IT. Which is equal to IT. 100 amperes of current. 100 amperes of current. Isn't it? So time is equal to 3 into 4 into 96,500 divided by 100. So T is equal to Q by I. I is 100 amperes. They are given 100 amperes. So what shall we do? This two you cancel. What you are getting is in seconds. Here how much you are getting in seconds. But see the answer, they are given it in hours. Answer, they are given it in hours. So this is seconds. If at all I want to convert it into hours, what I should do? 3 into 4 into 965, because 2 zeros are cancelled, divided by 3600. Because 1 hour is 60 minutes, 1 minute is 60 seconds. So to convert seconds into hours, you have to divide by 60 into 60, 3600. Right. See now how you have to do. Yeah. 36. 2 zeros let me cancel. 2 zeros let me cancel. Right. After cancelling 2 zeros, here 9.6. 9.6 I written, okay. After cancelling 2 zeros, what I wrote is 9.6 there. So it became what? I shall write here. It became 9.6, no? 9.6, 36, almost see here. 3, 9 ones are, 9 fours are. Am I right? 9.6, it is as 9. 9 ones are, 9 fours are. 4 ones are, then this is 4 ones. This is gone. 4 gone. Right. What remains is 3. Approximately 3 hours you get. Check the answer. 0.4, no. 0.8, never. 1.6 cannot be. 3.2 hours. This is how you can solve. You should not go on multiplying till the last digit. A little argument is required. You understood? My dear students, understood? Answer, I'll tell you what I say. See, 27.6 grams of diborane means it is 1 mole, because molar mass of diborane is 27.6. It comes. So 1 mole of diborane burns giving boron, trioxide and water. It requires 3 moles of oxygen. Now come to the electrolysis of water. Water undergoes oxidation giving oxygen and 4 electrons involved, means 4 Faraday. 4 into 96,500 coulombs. For 1 mole you require 4 into 96,500. But here what we need is 3 moles. For 3 moles how we need? 3 into 96,500. Okay. Then this is Q. Q is equal to IT. What I want is time. T is equal to Q by I. I is 100 amperes. First side you remove these 2 zeros. 965. 3 into 4 into 965. What you are getting is here in seconds. I want it in hours because the answer is given in hours. So you divide by 3600. Again approximation. So it was 965 right? So what I did is I removed 2 by dividing by 100. This I made it as 9.65. Then 9 ones are 9 fours are 4 I cancelled. What remains is 3. So almost 3 hours to get the approximate answer. Now compare the answers. Almost 3 hours means option C. Option C. This is how you have to use a little bit of logic also. Do not go on multiplying it, go on dividing it, because it is a cumbersome job. Yes. Next one. The anodic half cell reaction of lead acid battery recharged using electricity of 0.05 Faraday. The amount of PbSO4 electrolyzed in gram during the process is molar mass diagram. Let me write the reactions of the lead storage battery. At anode, what happens? Which reaction takes place? Oxidation. So don't bother about the charge. Where the oxidation takes place is anode. Anode is what? Loss of electron. Lead and sulfate ion. Where from it comes? Sulfate ion comes from the electrolyte. The electrolyte in lead storage battery is concentrated sulfuric acid. That gives sulfate ion. It gives lead sulfate and 2 electrons. This reaction taking place when we are using the battery for getting the current. It is a secondary battery. It can be recharged by passing current in opposite direction. When the recharging process is taking place, all the reaction becomes reverse. All the reaction becomes reverse. So during recharging, anodic reaction is PbSO4 gives Pb plus SO4 2 minus, right? After gaining 2 electrons. Such equations, any equations, ionic equations are to be balanced atom-wise as well as charge-wise. So 2 electron means 2 Faraday. 2 Faraday. So 2 Faraday charge if you pass, 1 mole of this will be electrolyzed. 1 mole of this will be electrolyzed. For 2 Faraday, 1 mole. 1 mole is how much? 303 grams. They are given 303 grams. 303 grams. So for 2 Faraday, 303 grams of lead sulfate is electrolyzed. Therefore, for how much they are given? How much they are given? 0.05. So for 2 Faraday, 303 gram. For 2 Faraday, correct? 303 gram of lead sulfate is electrolyzed. Therefore, for 0.05 Faraday. 0.05 Faraday. Okay? 0.05 Faraday. Yes. 2. Then it becomes 151, isn't it? 2. Then it is 151. Almost 151. 151 into 0.05. 151 into 0.05. It is 1.51 into 5, isn't it? This I have shifted the decimal 2 to that side. This I have shifted 2 to this side. 1.51 into 5. 1.51. 1.5 you take it as 1.5 into 5. 1.5 into 5 how much? 7.5. So 7.6 is the right answer. This is how you can use the simplification a little simple. Understand? See, 303. So you require how many? 2 Faraday. For 2 Faraday, 303 grams of PbSO4 is electrolyzed. But how much they are passing is 0.05 Faradays. What you do? 2 ones are 2 151s. 151 into 0.05. To avoid the confusion because of this decimal, you do one thing. Have a correct idea of shifting the decimal point. I have shifted this decimal point 2 to this side. So here you have to put the decimal point 2 to that side. So the change what I did is nothing. So 1.51 into 5. 1.5 into 5 is 7.5. So 7.6 is the right answer. Okay, this is how you have to use the little logic, children. Yes, it's an easy question. Many times appeared, easy question. They have given the electrode potentials of different, and they're asking the strongest oxidizing agent. See here, which has got the lowest value of electrode potential. See the value, minus 0.76, 1.51, 1.36, 1.33, 1.36. This has the lowest value. Lowest value means it has least tendency to undergo reduction, because all these are SRPs, reduction potential. Reduction potential least means lowest tendency to undergo reduction. This is the lowest, no? Lowest tendency to undergo reduction. Right? Which has got the highest value? Just see which is compare. Which has got the highest value? 1.36, 1.33. Ah, this is highest, isn't it? 1.51. This one, highest tendency to undergo what? Reduction. Right now, reduction potential higher means it has got a highest tendency to undergo reduction. That which has highest tendency to undergo reduction itself is the strongest oxidizing agent. An oxidizing agent never itself undergoes oxidation. An oxidizing agent does the oxidation of the other and itself undergoes reduction. Which has got the highest tendency to undergo reduction is the most powerful oxidizing agent. So, most powerful oxidizing agent is MnO4. This is the most powerful oxidizing agent. You understood? That having the highest value of electrode potential, it has the highest tendency to undergo reduction. So it is the most powerful oxidizing agent. That which has in electrochemical series, fluorine has got the highest value. Fluorine, top of the series. So most powerful oxidizing agent. Lithium at the bottom, minus 3.05, lowest value. So it is the most powerful reducing agent, because it has least tendency to undergo reduction, highest tendency to undergo oxidation, so most powerful reducing agent. Fluorine, highest tendency to undergo reduction, most powerful oxidizing agent. Okay, here the answer is this one, MnO4. Very simple question. Okay. Yes. Yes. A gas X at 1 atmosphere. Again, more or less same concept. Reduction potential Z, Y, X. I told you no. Higher the reduction potential, more powerful oxidizing agent it is. Is it not? Higher the reduction potential, more tendency to undergo reduction, most powerful. This is most powerful. Most powerful oxidizing agent. Why most powerful oxidizing agent? It has got the highest value of reduction. This is least powerful oxidizing agent. This is in between. This is also oxidizing agent. Correct? Not as strong as Z, but definitely more stronger than X. You understood? This is also an oxidizing agent. Not as strong as Z. It has got less value. But definitely more stronger than X. Right now, always we dominate over the person who are weaker than us. Isn't it? We never go to the person who is stronger. Here same thing has happened. Why? It cannot oxidize Z. Z is much more powerful oxidizing agent. It can oxidize X because X is weaker. X is weaker. So what is the right answer? Y oxidizes X but not Z. Y oxidizes X. Why? Because X is weaker oxidizing agent than Y. Why it cannot oxidize Z? Z is a much more powerful oxidizing agent. Right? Which is the right option? Y oxidizes X, but not Z. But not Z. Understood? If it is still more powerful oxidizing agent, this cannot oxidize that. If it is a weaker oxidizing agent, this becomes stronger, then this will encash its power. That's a simple logic. Yes. Next one. So this is the answer. Next one. EMF of an hydrogen oxygen fuel cell independent of partial pressure of hydrogen, different. What is the net reaction involved in hydrogen oxygen fuel cell? That is 2H2 plus O2 giving 2H2O. This is the overall reaction. This is a gas, this is a gas, this is a liquid. Overall reaction. Right. That's why we say fuel cells are environmental friendly. They don't contribute anything which is responsible for pollution. After all, the product is water. In fact, these are the cells which are used by spacecraft. They are getting current from this, and whatever byproduct water we are getting, they are condensing it and using it for their daily activities. That's, yeah. How will you write it? E cell is equal to E naught of the cell, right, minus 0.059 by n log to the base 10 of, yeah, which comes in the denominator. This comes in the denominator. The one which is there to the left side comes in the denominator. This will leave it because it is a pure substance. Pure substance gas you cannot leave because their partial pressures will differ. If it is a liquid or solid, just leave it. 1 by, okay, 1 by partial pressure of H2 square into partial pressure of O2. Is it not? This is 1. I'm not happy with this minus sign. What shall I do? E naught of the cell plus 0.059 by n log to the base 10 of, I change here, partial pressure of hydrogen comes in the numerator. So also partial pressure of oxygen. Agree? I changed negative sign to positive sign. So what I should do is, this also, from the terms from the numerator, I should take it to the denominator. Now see here. Independent of partial pressure of H2 and O2, never, because both are there in the equation. Both are there in the equation. Right? Decreases with increase in partial pressure of H2 and oxygen. That's also not true. Because both these partial pressures are there in the numerator. Here is plus sign. So when partial pressure of hydrogen and oxygen increases, it should increase. Increases with increase in partial pressure of H2 and O2. Is it not the right thing? Don't you feel that option C is the right thing? Because when they are in the numerator, here is plus sign. So obviously, when these two increases, E cell also should increase. E cell also should increase. E naught is fixed. Varies with the concentration of OH minus ion. No, because OH minus ions are not there in the picture, in the equation. So option C is correct. Option C is correct. Okay? Yes. Yes. The product obtained from the electrolytic oxidation of acidified sulfate solution. Acidified. Sulfate, what is the formula? SO4 minus 2. Oxidation means loss of electron. 2 sulfate gives S2O8 double minus 2 plus 2 electron charge by spectrum. Acidified means there will be good number of hydrogen ions now. This hydrogen ions from the acid combine with S2O8 minus 2 giving H2S2O8. H2S2O8. This is called peroxodisulfuric acid. Peroxodisulfuric acid. That's called peroxodisulfuric acid. I shall write the formula of that. S double bond O, S double bond O, OH, OH, 1 mole double bond O, 1 mole double bond O, O, this is H2, S2O, 1, 2, 3, 4, 5, 6, 7, 8. Peroxodisulfuric. Right. Now here, each unit contains, right, which bond it is? Which bond? H, SO, SC now, which one? H, O3SO, H, O3SO, is it not? H, O3SO, HO3SO. This is correct, no? In between two oxygens are there. In between two oxygen. H, O3, S, O, S, O3. This is the right answer. Okay, this is the right one. Option B is the right. This particular acid, they asked it many times to calculate the oxidation number. Many times they ask. If you flatly calculate the oxidation number with this formula, each oxygen is -2, 8, -16, 2 gone, -14. From 2 sulfur -14, +14. So 1 sulfur looks like +7. Looks like +7. If you calculate the oxidation number, plain. But it is not +7. Sulfur cannot show an oxidation state more than 6. Where we have gone wrong. This oxygen is -2. This is -2, -2, -2, -2, -2, fine. These two oxygens, peroxide linkage, peroxodisulfuric acid, each oxygen is -1, not -2. So taking this as -1, if you calculate, it will be +6 only. Right? So to calculate, find out the oxidation number, you require the formula. You cannot find out the oxidation number in every case by looking at the correct molecular formula. You require the structure. These two oxygen atoms are peroxide linkages. Peroxide linkages. You have to take it -1, -1. If you calculate like that, it will be +6 only. We are right within the frame. Because sulfur cannot show an oxidation state of more than 6. More than 6. This question they have asked many times. Yes. In an experiment, 0.4 Faraday was passed through 400 ml of 0.01 m sodium chloride solution. The pH of the solution after the electrolysis. Let me write the net reaction involved in the electrolysis of aqueous sodium chloride. NaCl plus H2O. 1 electron is involved. Na plus ion you get. OH minus ion you get. Then you get half chlorine. Then you get half hydrogen. Chlorine is at the anode. Okay. Hydrogen is at the cathode. Hydrogen is at the cathode. This is a net reaction taking place when an aqueous solution of sodium chloride is electrolyzed. It involves 1 electron, means 1 Faraday. 1 Faraday. 1 Faraday gives 1 mole of OH minus ion. What we want is this OH minus. For pH, what we want is this OH minus. 1 Faraday gives 1 mole of OH minus. Therefore, 0.04 Faraday. 1 Faraday gives 1 mole of OH minus. Therefore, 0.04 Faradays. Because what they are passing is 0.04 Faraday. Right? It is 0.04 mole of OH minus. in 400 milliliter. Volume of the solution is 400 milliliter. I want concentration of OH minus, that is mole by liter. Mole by liter, concentration, molar concentration, mole per liter. Number of moles is 0.04. Volume of the solution in liter is 400. You have to divide by 1000. So 0.4. 400 milliliter means 0.4. Right. So it is 0.04 by 0.4. That is 10 to the power 0.04 by 0.4. Right. 10 to the power minus 1. This is the concentration of OH minus. So whenever you use molar concentration, then only you can use square bracket. This is the concentration. Right. You know that hydrogen plus, into hydroxide is equal to 10 to the power minus 14. Right now, in any solution at 298 Kelvin, of course, product of hydrogen and hydroxide concentration is 10 to the power minus 14. So I want hydrogen ion concentration. That is 10 to the power minus 14 by hydroxide. That is 10 to the power minus 14 by 10 to the power minus 1. Is it not 10 to the power minus 13? So hydrogen ion concentration is 10 to the power minus 13. Last step, pH is equal to minus log to the base 10 of molar concentration of hydrogen ion. Minus log to the base 10 of 10 to the power minus 13. Log 10 to the power minus 13 is minus 13. Since negative sign is there already, the answer will be 13. This is the answer. Option D is the right answer. Right? This is the net reaction involved in the electrolysis of aqueous solution of sodium chloride. Involves 1 electron, 1 mole of OH minus. 1 Faraday gives 1 mole of OH minus, but what they have passed is 0.04 Faraday. You should get 0.04 mole of OH ions. That is 400 ml of the solution. I want concentration in mole per liter. Number of moles by volume of the solution in liter. 400 ml, if I divide by 1000, I got 0.4 liter. So we got it 10 to the power minus 1. That is the concentration of hydroxide ion. I want hydrogen ion, ionic product of water we say. In any aqueous solution, product of hydrogen ion and hydroxide ion is 10 to the power minus 14. So if you want hydrogen ion, 10 to the power minus 14 divided by hydroxide, that becomes 10 to the power minus 13. Last step, pH is equal to minus log 10 to the power hydrogen ion minus log 10 to the power minus 13. Log 10 to the power minus 13 is minus 13. Since minus sign is already there, the answer will be 13. Option D is the right answer. Yes. See here. A fuel cell involves combustion of this one, isn't it? E naught will be. So formula is simple. Delta G is equal to minus NF E naught of the cell. Simple formula. We have used it several times. Right? How to find out N? That is the problem. C4H10. Right? We don't want this. 4CO2. Of course, the equation is not balanced. Here it requires something, isn't it? Can you tell how much it is? C4, 4C, 5H2O, 8, 13. It will be 13 by 2, isn't it? 5, O, 4 into 2, 8, 8 plus 5, 13. It will be 13 by 2. Small correction. Anyway, we don't want that. C4H10. Finally, it gives 4CO2. Right. What is the oxidation state of hydrogen? +1. Except in metallic hydride where it is -1, it is not metallic hydride, +1. Contribution from each hydrogen is +1. Right. How many hydrogens are there? 10. So from 10 hydrogen plus 10, so from 4 carbon how much? -10. You understood how it is? Each hydrogen is +1. 10 hydrogen are there. Contribution from hydrogen is minus 10, plus 10. So from 4 carbon, minus 10. Come to this. Each oxygen is 2 minus. 2 oxygens means 4 minus. Each carbon is 4 plus. Each carbon is 4 plus. 4 carbons are there. Each carbon, you understood? Each oxygen is 2 minus. 2 oxygens are there, 4 minus. Each carbon should be 4 plus. But 4 carbons are there. 4 carbons plus 16. Right? So N is change in oxidation state. Final minus initial. N is minus plus 16. Final. Minus of minus 10. Yeah. How much you got it? 26. Only the problem is this. 26. Right? Final is a plus 16. Minus initial is a minus 10. This initial is minus 10. So it is 26. Now come to this. Come to this. D naught is equal to N is how much? Minus. N is how much? 26 into F is 96,500. Okay. 96,500 into E naught of the cell. Delta G, how much they are given? Minus 2746 kilojoule. Minus 2746 kilojoule. Right. I want E naught of the cell. Minus 2746. I shall multiply it by 1000. You understand why? Why I multiplied by 1000? Because kilojoule, I want to convert it into joule. So I multiplied by 1000. Divided by minus 26 into 96,500. Right? How you got this? Minus minus gone. Minus minus gone. See here. Digits to calculate. 1, 2, 3, 4, 5, 6, 7. This also 1, 2, 3, 4, 5, 6, 7. No. Almost same. It is 27. It is 26. So numerator is slightly more than the denominator. That's all. Right. So which value we can expect here? Numerator is 27. This is 26. Slightly more. Right? Almost same, but slightly more. So the answer should be slightly more than 1. This is the right answer. 1.09 volt. That's the right answer. You need not simplify. Only the problem is to calculate N. To calculate N. Right? Once again I shall tell. This is the equation now. Only the problem is to calculate the N. Each hydrogen is plus 1. 10 minus 10 plus. So from 4 carbon minus 10. Each oxygen is 2 minus. 2 oxygens are there in one molecule. 4 minus. Each carbon is 4 plus. But 4 carbons are there plus 16. N is change. Final minus initial. Plus 16 minus of minus 10. It becomes 26. This is the formula. They are given this. N we have calculated. This 96,500. E naught of the cell you keep it as it is. Our purpose is to find E naught of the cell. This value they have given it in kilojoule. I multiplied by 1000 and get it in joule. So divide it. Minus minus cancel. So if you compare the values of the numerator and denominator, numerator is slightly greater than the denominator. So the value is slightly more than 1. Correct answer is 1.09 volt. That's the correct answer. Yes. It's a simple question. For the reaction they are given, E naught they are given. Then what they have asked? What they have asked? E naught they are given. They are given cell potential at 25 degrees centigrade. Cell potential. E cell is equal to, yeah, come on, E naught of the cell, which they are given, minus 0.059 into N log to the base 10 of. See the reaction. What all are the items comes in the numerator? Right side should come in the numerator, no? Fe plus 2 of that square. Am I right? Fe plus 2 of that square. Water I should leave it because it is a pure substance. Solids and liquids, pure substance, you should simply give it up. Leave it. Their activity is taken as 1. Here also this you have to give it up. Oxygen is a gas. Partial pressure of oxygen into concentration of hydrogen ion of that power 4. Concentration of hydrogen ion of that power 4. This is the equation what we got. Right. Now substitute. E naught, how much they have given? E naught 1.67 minus 0.059. N value how much? N value 2Fe, 2Fe2 plus. N value is 4. N value 2Fe, 2Fe plus 2. N value is 4. Log to the base 10 of. What is iron concentration? 10 to the power minus 3. 10 to the power minus 3 of that square. Yeah. Partial pressure of oxygen. We want here in the denominator. Partial pressure of oxygen how much? 0.1. Is it not 0.1? 0.1 into. Yeah. What is the concentration of hydrogen ion? They are not directly given it, but they are given pH 3. When pH is equal to 3, concentration of hydrogen ion is equal to concentration of hydrogen ion is equal to 10 to the power minus 3. This is how they are interrelated. When hydrogen ion concentration is 10 to the power minus 3, pH is 3. Or when the pH is 3, hydrogen ion concentration is 10 to the power minus 3. 10 to the power minus 3 of that to the power 4. Of that to the power 4. Right? That is equal to, I'll continue it here, 1.67 minus 0.059 by 4 into, see here, minus 3, 4, 10 to the power minus 3, 4, minus 12. Minus 12, this is 1. Minus 13. When it went to minus up, plus 13. Here it is 3 into 2, 6. Okay, minus 6 plus 13. How much remained? 7 remained. Log of 10 to the power 7 is 7. Into 0.05 into 7. You understood how you got this 7? I'll tell it once again. 10 to the power minus 3 square is minus 6. 10 to the power minus 3 to the power 4 is minus 12. Here is 0.1. 10 to the power minus 13. Minus 13 when went to the numerator, it became a plus 13. Plus minus 6 plus 13. Minus 6 plus 13. 10 to the power 7. Right? What is log 10 to the power 7? Log 10 to the power 7 is 7. Log 10 to the power 7 is 7. Right? Yeah. You take it as 0.06. Approximation. 1.67 minus 0.06 by 4 into 7. How much it is? 0.06 into 7. 0.42. 0.42 by 1. 4. 1.67. 1.67. Okay. 1.67 minus 0.42 by 4. So 1.67 minus 0.42 by 4 is 0.1 almost. 1.67 minus 0.1. What is the right answer? 1.57. 1.5. Yes, it is there. 1.57. It is there. 1.57 volt is there. Explain it again. See here. See the formula. Write an equation for the E cell. E cell is equal to E naught of the cell minus 0.059 by n log to the base 10. What is there in the right side comes in the numerator. What is there in the left side comes in the denominator. Then what we did, I substituted the value here. N value is 4 because anyone you have to concentrate. 2Fe, then 2Fe2 plus, difference is 4. Okay, then what I did, this, if I simplify, it will be log 10 to the power 7. Log 10 to the power 7 is 7. So 7 into, this I took it as 0.06 instead of 0.059. So 0.42 by 4 is 0.1, 0.67 by 0.1, 0.57. This is the right answer. Right. Yes. Yes. Rusting of iron takes place like this. Delta G for the net process is delta G for the net process. Yes. Here it is a reduction, na, cathode. Here it is a, right now, oxidation. Here it is oxidation. So how will you calculate? Here it has undergone oxidation, isn't it? This is anode. Undergone oxidation, loss of electron. Here gain of electron. This is cathode. This is cathodic reaction. E cell is equal to E of cathode minus E of anode. Yeah, what is that E of cathode? E of cathode is what? 1.23 minus of minus 0.44. So it becomes plus, isn't it? How much it becomes? How much it becomes? 1.23 plus 0.44. 1.67. Am I right? 1.67 volt. Then what they asked? Delta G naught is equal to minus NF E naught of the cell. That is equal to minus N is how much? N is how much? Anyone you concentrate? 2 electrons now. N is 2. F is 96,500. Then E naught of the cell, we got it as 1.67. So many joules it will be. But the answer given is in kilojoule. Answer given is in kilojoule. Divided by 1000. Right? So what you are getting is in joule. I want it in kilojoule because the answer what they are given is in kilojoule. Yeah, what will you do? 1030 gone. Here you put a point. Put a point. Okay. 100, you take it as 100. 100 into 2. 100 into 2. 200. 200 into 1.675. If it were 1.5, it would have been 300. 200 into 1.5 would have been 300. 1.67, a little more than 300, but with minus sign. A little more than 300, but with minus sign. Option A is the right answer. Option A is the right answer. Okay. So this is how you must make use of a little logic, a little shortcut, everything you have to make use of. And you should be quick as well as accurate. You cannot compromise about anything. ಪ್ರಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇಷ್ಟೊತ್ತು ನಾನು ಇಂಗ್ಲಿಷಲ್ಲೇ ಮಾತಾಡಿರೋದು ಕಾರಣ ಇಷ್ಟೇ. ಸೊ ಕೆಲವು ಟರ್ಮ್ಸ್ಗಳೆಲ್ಲ ಇಂಗ್ಲಿಷಲ್ಲೇ ಯು ಆರ್ ಮೋರ್ ಫ್ಯಾಮಿಲಿಯರ್ ವಿತ್. ಬಟ್ ವಿಚಾರ ತಿಳ್ಕೊಳ್ಳಿಕ್ಕೆ ಲ್ಯಾಂಗ್ವೇಜ್ ನೋ ಬಾರ್. ಕನ್ನಡದಲ್ಲಿ ಬೇಕಾದ್ರೆ ತಿಳ್ಕೊಳ್ಳಿ, ಇಂಗ್ಲಿಷ್ನಲ್ಲಿ ಬೇಕಾದ್ರೆ ತಿಳ್ಕೊಳ್ಳಿ. ರೈಟ್? ಸೊ ಎಲ್ಲ ಒಳ್ಳೆ ನಿಷ್ಠೆಯಿಂದ ಪ್ರಯತ್ನ ಮಾಡಿ, ಖಂಡಿತ ಯಶಸ್ಸು ನಿಮ್ದಾಗತ್ತೆ. ಸೊ ಎಲ್ಲರಿಗೂ ಒಳ್ಳೇದಾಗಲಿ ಅಂತ ಹಾರೈಸ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಪುನಃ ಸಿಗೋಣ.